All right, looks like most of the class is here, so we can probably get started. I hope you guys are all doing well and staying safe. Okay, and again, I started recording our session, so in case you need to re-listen to something, or see something again, or if you miss one of the meetings by any chance, you can look at that again. And so let me show you, I think I just have one from the last meeting, and I'm recording this one as well. And the recordings will go up on Blackboard. So I have it for that meeting. Okay, I think I'll make an extra folder or space for the recordings, but the one from last week for chapter 3 is right there under the chapter 3 stuff. And so that's chapter 3's WebEx recording from last week, the whole thing. And I'm recording this week, and I'll try to keep recording every week, because just in case you guys need to refer to something back again, it might be helpful. Okay, so it looks like everyone's found out how to post their work to the discussion forum in the right spot, and so looks like almost all the homework's already in for the previous 2 homeworks, which is great. And so you guys know what to do for that. We'll have another homework today assigned. It's pretty short for chapter 4. And again, that elasticity homework is due a few weeks down the road. So that's due Friday, May 1st. And so that's the thing we started last week. Okay, and so I got a few emails, and I think I answered your questions about elasticity homework. But it's not due for a few weeks. But any questions or problems thus far with elasticity homework, any of the Excel or data analysis questions? Okay, it seems like you guys are okay on that. And again, if you do come across any questions, let me know. I did put my example up that you can look at as a reference. Okay, so it's right there. I did that one for Illinois as an example. And so you can look at that just to make sure, if you have any questions, what to do with the Excel and the data analysis. Okay, so if there's no more issues on the previous work, we can go ahead and get started on today's new material, which is chapter 4. Okay, so chapter 4 in your textbook, we're going to talk about some theories of individual behavior and some indifference curve analysis and from the consumer side. And also the chapter 3 homework is due today, and it looks like most of you already turned that in, so just a reminder. And the homework for chapter 4 is going to be due next Monday. Okay, so we can open up for chapter 4, we can open up the chapter 4 Word document, and then I'll also open up the chapter 4 PowerPoint that we can look through. And I'll also refer to the previous PDF edition of the textbook so we can look at some of the figures. Okay, so I think that's what we need for chapter 4 for right now. So we'll look at the later, but we'll look at the Word document, the chapter 4, and then the PowerPoint. Okay, so again, the usual thing, if you have any questions, I'll look at the chat feature, or you can also always ask some questions just by turning your sound on. Okay, so I'm not sure if we did indifference curves in Viz 500B. We might have. I sometimes teach some of this topic in like Intro to Econ, but I don't know if we did. So this might be a new material, but it's not too bad if it is. And so we're looking at kind of how consumers model and maximize their behavior and maximize their choices using a difference curve analysis. All right, so let's just start with figure 4.1, which just shows a hypothetical indifference curve. Okay, so you'll see something like this, where it kind of represents the choice a consumer might make between two goods, and this two-good analysis can be applied to any number of goods, but we'll stick with two because the two-dimensional model is funny enough to understand what this is saying. And so if we have two goods, good Y and good X, okay, and you have some kind of indifference curve, which represents a curve in which the consumer maintains the same level of satisfaction on any point of the curve. So this red curve here on the figure, any point on there, the consumer is indifferent to be on, and so therefore each point is the same satisfaction or utility. And you can see that if the consumer gets more balanced bundles, like a fair number of like an equal amount of X and Y, good X and good Y, then this is preferable to like extreme amounts. So any point on this curve, the consumer is indifferent. So the point A you see, the point B, the point C, any point on this curve or a given indifference curve is equal satisfaction for the customer, for the consumer. Okay, and so that's just what that represents is a given indifference curve, the same satisfaction at any point. Now, sometimes you can get a higher or low indifference curves, but on one indifference curve, the consumer is indifferent, just kind of like the curve states. Okay, so in this example, the consumer is indifferent from 6 units of Y and 1 unit of X, 4 units of Y and 2 units of X, and all those different combinations are all the same satisfaction. Okay, and then the slope of this curve is kind of the rate of trade-off, or the opportunity cost of giving up one good to get more of the other. So just looking at this curve, and if you move along a difference curve, then if you go this way from A to B, you're gaining X and losing Y. So if you're going to get more X, you have to give up some Y at some trade-off rate. Right? So any point you go to, if you get more of one good with the same income, you have to give up some of the other. Okay, and the rate of trade-off we call this is the marginal rate of substitution, or the MRS. And so this is, like it says here in the definition, the rate at which a consumer is willing to substitute one good for another and still maintain the same level of satisfaction. So that's basically saying that's the slope of the curve, because going from a different point, from one point to another on the curve, by definition gives you the same level of satisfaction, so it has to represent this rate of trade-off. Okay, so the rate of trade-off or the slope of the curve is called the MRS, and that shows you if you want to get more of one good, how much of the other you have to give up. And you can see this curve is kind of nonlinear in the sense that the trade-off or the MRS changes from point to point, right? And so it depends where you are to determine the rate of trade-off, but the rate of trade-off is always the MRS. Okay, so just look at from going from A to B, and let's see. So we gain 1x if we start at point A, and we gain 1x. And we go from A to B and go from 1 to 2 of x. We have to give up 2y. So the rate of trade-off starting at point A to gain 1 more x is giving up units of y. Right? So that's the rate of trade-off, and it depends on where you are. But the calculation of the slope of getting more of the other good is what you give up from the good that you're not getting more. Okay. So the slope of any indifference curve is equivalent to the MRS, the rate of trade-off. Okay, and so we can probably understand that the consumer wants to achieve the maximum level of satisfaction if possible, and the consumer is constrained by something. Usually we call this income or budget constraints, and so we're going to introduce budget constraints because the consumer wants to get or achieve as much utility as possible by consuming both goods, but he or she is constrained by how much income or salary or wages they can earn, and so they can't achieve more utility than they have constrained by their income. Do you have a question? No? Okay, and then here, before we move to the budget lines, you can see this is just a family of indifference curves, and so just what this represents is, hypothetically a consumer has an unlimited number of indifference curves, and they all represent kind of the same shape, and that shape is unique to the consumer because he or she has different rates of trade-off. But so like all points on indifference curve I give the same level of utility. All points on indifference curve 2 give them the same level of utility, but the farther out curves give more utility. So every point on a given indifference curve is the same utility, but if you can get to a higher level, then you get more utility. So utility curve 3 is higher, yields more utility than the bottom two. Okay, so we will introduce the budget line or budget constraint. And so the budget line is the bundles of goods that exhaust the consumer's income. So we're going to assume that the consumer, there's no leisure choice right now, it's just consumption. And so in this model, the consumer maximizes his or her utility by consuming all the goods possible, given an income level. Okay, so if we say that the price of good X is CX, and the price of good Y is CY, and income is M, then how much the consumer spends on good X plus how much the consumer spends on good Y has to equal the total level of income because he or she is going to exhaust her income. Okay, so you can see that budget line is the price of good X times X plus the price of good Y times Y has to equal M, the income, because to get to the highest level of satisfaction, the consumer has to exhaust all of that income on either good X or good Y. They can move around on the budget line, but to achieve the most satisfaction, we're assuming they exhaust their income. Okay, and then just so you know how the curve kind of sits on the same graph of X and Y, if you kind of rearranged and solve for Y, so right here in this step, what do? We divided by PY, all right, and then we just subtracted px divided by py times x on both sides, and if we rearrange this one, we can get this one here, right? So it's just, all we did was rearrange and solve for y. Okay, and what that does is on the xy axis, it shows you how these numbers or notational terms fit into the map here. So if this is the equation, y equals m over py minus px over py times x. Okay, that's the same thing as the other budget line, is just rearranged as a function of y. Okay, so then you know where kind of the intercepts are, or how you plot this on the indifference curve graph. Okay, so to get the y-intercept, if x is 0, then the intercept is m over py, right? And so that would be right there. And if you did the same thing and solve for x, you would get that the other intercept is m over px. Okay, so it's a straight line, which represents how much income the consumer can have. And so you see that kind of the budget set. And again, this is good y, and this is good x. Okay, then any point on that line or under the line, the consumer can buy or consume. And any point, like point H, beyond the line, they cannot consume because they don't have enough income, right? And so what we're going to see is the consumer would like to use all of his or her income, but get to the highest level of utility possible that's available. Okay, so this is pretty simple, but I think I have a little homework, or just not a homework question, but a question that we'll look at later on the market rate of substitution. And so this is just the rate at which one good may be traded for another in the market, and it's also the slope of the budget line. So it's very important, very simple, but very important. Where that term after there is negative px over py. So the rate of trade-off is obviously determined by the price of both of the goods. Okay, so if the price of good X goes up, then that means you're going to consume more of Y, and vice versa. So how much you buy of each is directly determined by the price of those goods, because if those prices change, that means your budget line changes, because either one good got more or less expensive, and if that happens, then you have to move your budget line around. Okay? The slope of the budget line is always negative px over py, which we call the market rate of substitution, and that's always the case, but that depends on what the current prices are of both the goods. And so the slope of that budget line is negative px over py. So before we get to continuous equilibrium, let me just, I think there's a couple graphs showing you what happens if your income changes. Okay, so this is pretty simple, but it's important to understand how the model works. Is if we start at the black curve, or the black line, this one, and if the consumer gets more income, the budget line just shifts out like that. It's the same exact, the slope of the curve is the same exact thing because the price ratio didn't change, but the consumer got more income, so you can see that if the consumer gets more income, then this intercept shifts out because M got bigger, and this intercept shifts out by the same amount because M got bigger. So more income go this way, and if the consumer loses income, the budget line shifts the opposite direction. But if just income changes, the budget line shifts up or down, but at the same rate of trade-off, the same px over py slope. Okay, and what about if a price changes? So if the price changes, then that's going to change the negative px over py rate of trade-off. So that's exactly going to change the slope because that is the slope. Okay? So if the slope of the curve is the slope of the budget line is negative px over py, and one of those prices change, either px or py, then the slope has to change because that is the slope of the curve. So if figure 4.6 we have a decrease in the price of good x, okay? So that means that the consumer, nothing really happened to y, but the consumer can buy more of x because the price went down. So we kind of kick or shift the budget line like that, okay, because there's a new intercept for the price of good x. Okay, so if m over px is the intercept and px got lower, then that intercept had to get bigger, which makes sense because if the price goes down, the consumer can buy more of good x. So decrease in the price of good x would just do that kink where the red line or the pink line is the new budget line. Okay, but what if we had the opposite thing where we had an increase in the price? So an increase in the price, you have the budget line shifted the other direction. So if the intercept is m over px, we know that, and px increases, that means the whole intercept got lower, and that should make sense because the consumer can buy less of good x if it got more expensive, so the budget line shifts the other direction. So this shows an increase in the price of good x where the budget line kinks out, and you can see the new red curve with a higher price of x. Okay, so we're trying to get to consumer equilibrium, which is the point of this model. And so we started with an indifference curve. Then we showed there's a bunch of possible indifference curves. Then we showed that there's a budget line the consumer is constrained by. He or she can't consume more than the income they have allowed in the budget. So therefore, they want to get to the highest indifference curve possible, constrained by the budget. So that leads us to a point of consumer equilibrium, which is this is the affordable bundle that yields the greatest satisfaction to the customer. So this is as far as they can get, or they can get. This is the highest indifference curve the consumer can get to, given their budget line. All right, so see the indifference curve shapes. So what the consumer wants to do is get as far out as possible. Okay, so this lower curve is attainable given the budget line, but you can see that the consumer can do better. The second one as well, indifference curve 2, is also attainable, but the best possible option is indifference curve 3, where they get to point C, and that's the highest level of satisfaction the consumer can get given this budget line. There's no, so basically any indifference curve below that, the consumer can do better, and any indifference curve beyond that is not affordable. So the point of consumer equilibrium, where the consumer maximizes utility based on their constant income, is point C. So it's just a point where the highest level indifference curve is tangent or just touches the budget line. Okay, so everybody following so far? Okay, great. All right, so just like any model, we kind of have to set it up, and then the fun stuff is figuring out what happens if something changes. So what if So what happens to the consumer equilibrium if income goes up or down, or if the prices goes up or down? And that depends on the income change, on the price change, and if the goods are substitutes or complements in the price change example, or if the goods are normal versus inferior in the income change example. Okay, so when something changes, we're going to automatically get a new consumer equilibrium. Now, if the consumer gets more income or one of the prices goes down, then they're automatically going to get to a higher level of utility because they either have more income by getting more income or they have relatively more income because they can buy more with the same income because the price went down. And so we don't know exactly where the consumer will be. It depends on the situation. But if either price goes down or income goes up, they get a higher level of utility, a new, better consumer equilibrium. Okay, so just look at this example. This is a change in consumer utility due to a decrease in the price of good X, so they're going to get higher. But note that good Y is a substitute for good X. Alright, so we start there at point A, and this is in difference curve 1 where they initially started at consumer equilibrium, and then what happened is the price of good X decreased. So we know what happens there. If this price gets smaller, then this intercept shifts out because this M divided by a lower price, a lower PX, is bigger, and if the price of good X goes down, the budget line shifts out, or kinks out like that, because the consumer can buy more. But we were told these are substitutes, and so that means, remember we know from supply and demand that if the goods are substitutes, and one of these substitutes gets a lower price, then the consumers buy more of that good, and less of the other. So you can see at point D, this is a higher level of utility, a more, the indifference curve is farther out because of the new budget line, but at the new equilibrium, the consumer bought less of good Y because there was a substitute and a lot more of good X. So you see the new Y is lower and the new X is a lot bigger, and that's because the goods are substitutes, but again, the consumer is better off. It's just got a lot more of the substitute because the consumer doesn't care so much which good it consumes because X is a substitute for Y. And if the price of it, and if one of the substitutes gets cheaper, and it's pretty much the same thing, the consumer can buy more of that good because it's more affordable. Okay, and what about if the goods are complements? So remember, this was like coffee and cream, milk and sugar, like ketchup and mustard, things that are consumed together. So here, figure 10, if the price of good X falls, what happens to the new equilibrium if they're complementary goods? Okay, so we have the same exact shift. The budget line kinked out, and there's a higher intercept on the x-axis because the price of good X went down, so the budget line shifts out. Right? If the price of the good goes down, the consumer can buy more of it. Okay, so the budget line shifts from the black budget line to the pink one, and because these are complements, the consumer buys more of both. Right? So it consumes these goods together. And it's probably going to buy a little bit more of the cheaper one, which it did with X. But if they're complements and the consumer gets more income or one of the prices goes down, then it's going to consume more of both because those goods are consumed together. So you can see the new equilibrium point D, the consumer consumed more Y and more X. All right, so just notice the difference between the substitutes and the complements. for those two figures. Okay, what if we have an income change? So we already know what happens to the budget line if there's an income change and nothing else changes. So if M increases, which is income, consumer can buy more, consume more because it has more income. So if M goes up, then M over PY goes up, and M over PX goes up, which are both the intercepts for the budget line. And so because the PX over PY ratio, the price ratio didn't change, the income increase just shifts the budget line to the right. Okay, and we get we start at point A at the lower summary equilibrium, and then with the income increase, we go to the difference curve, the budget line of the pink one, and we get to point B, and because these are both normal goods, the consumer is going to buy more of both at kind of the same ratio. So the point B is it's almost like a 45-degree line from point A, and the consumer buys pretty much an equal amount of both goods. More amount of both goods given the income increase. So income goes up, both goods are normal goods, the consumer buys more of both. That's pretty much the same ratio. Alright, so this one's a little weird because you have to notice what they're telling you. So this is an increase in income, but good X is an inferior good. So we know from the supply and demand analyses that if you have an inferior good, if your income goes up, you buy less of it, and vice versa. So there's a negative relationship that we learned in Biz 500B and Chapter 2 here, that if you have an inferior good, that means you only buy more of it when your income goes down. If your income goes up, you buy less of it because you consume more of the good you prefer to have with additional income. Okay, so we start at point A, which is the original budget line. And then the same thing happens, we get more income, so the budget line just shifts out with the same PX over PY ratio. Alright, so the pink budget line. But the new higher indifference curve, the consumer's better off, but because they got more income, they're going to buy way more of the normal good that they like to have and less of the inferior good. So at point B, the new consumer equilibrium, you can notice that the consumer bought a lot more of good Y, which is a normal good, but they actually bought less of good X because that was an inferior good. So the inferior good analysis, you know that if income goes up, you buy less of it, and this is how you represent that on this model. Okay, so the next thing is the substitution income effect. And what this little graphical analysis does is it kind of breaks the changes into two effects. And so you have a substitution effect, because if one of the price changes and one of the goods become relatively cheaper, you buy more of the cheaper good. And there's an income effect, because if the price changes, you have more or less purchasing power, which affects your real income. It's like having inflation or having prices go down. Okay, so let me see where there's definitions, formal definitions for the substitution effect and income effect. we go. Okay, so you always do the substitution effect first because it occurs on the original indifference curve before the change. So the substitution effect is the movement along a given or the initial indifference curve that results from a change in the relative prices of goods, holding real income constant. So if one of the prices changes, how does that affect your consumption versus X and Y? So basically, whichever good gets more expensive after the price change, you buy less of that and more of the cheaper one. So you just substitute the more expensive for the cheaper. Okay, and the income effect due to a price change is the movement from one indifference curve to another that results from the change in real income caused by the price change. So basically, if the price of either good goes down, you have more real income because with the same level of income, you can buy more of the bundle because one of them is cheaper. So your purchasing power went up. And if the price of either of the goods goes up, your purchasing power went down. And this is just like inflation in the real world, where you can buy less because now the goods are more expensive. Okay, so the substitution effect occurs on the original difference curve, and the substitution effect, the income effect is the movement to a different, higher or lower difference curve. Okay, and so what figure 4-13 shows is an increase in the price of good X, and it also shows the substitution effect and the income effect. Okay, so the only thing that changed here is the price of good X increase. So we started at point A, at the consumer equilibrium at that NGT, and the price of good X increase. So that means the difference curve, the budget line kinks in because the price of good X is higher, and so the consumer can buy less of it. So the intercept changes, M over PX, because the PX is now higher, so it's lower. So this, the kinked in budget line, see that, that's due to the fact that there's an increase in the price of good X. Alright, so we know we're going to lower indifference curve, but we can break this effect into two parts. So the first is the substitution effect, and that's going from A to B. Alright, so that simply shows that the consumer just substituted more Y for X because Y is now a little bit cheaper. So anytime one of the goods gets more expensive, the consumer is going to probably buy a little bit more of the other because it's now more affordable. So that trade-off, or that substitution, occurred on the original indifference curve, the movement from A to B on that first indifference curve. Okay, and then the movement from B to C is the income effect because the consumer is going to buy a little bit less of both after the change because it has less purchasing power due to the price increase. Okay, so A to B is the substitution effect, B to C is the income effect. And the substitution effect occurs on the original difference curve, and the income effect is moving to a lower, in this case, indifference curve, because the real income of the consumer has decreased due to the price increase. Okay, so that's the total effect kind of broken down into substitution plus income effect. Okay, do you guys see that? And so we're not going to do a whole lot of substitution income effect, but I just want you guys to understand the example. And so it depends on which price goes up or down, and if the goods are substitutes or complements, right? Then you have to break it down differently. It actually also depends if the goods are normal or inferior, or some combination of both. Okay, and so there's an optional video if you guys want to watch later on that shows a good analysis on YouTube of the difference curve changes. So the first one on the chapter 4 Word document is just on intro to indifference curves. If you want some more on that, the second one breaks down more and shows more details of all the different substitution income effects. And it's kind of nice to see how it's different if the goods are normal versus inferior. There's a bunch of different cases. The logic and the definitions are the same, but it depends if one is inferior versus the other. And the last video is really just optional. It shows kind of the calculus behind consumer maximization. You don't really need to know that. I've taught this concept in the past, but it's kind of outdated, and it's a lot of calculus to get not too much. And so it's interesting to see if you like calculus, but that last video is definitely optional. Okay, so any questions on the substitution and income effect that occurs on the graph? Okay, so let's look at how you derive the domain curve, graphically derive the domain curve from indifference curve analysis. So this is kind of an interesting concept how it leads us back to the domain curve for one of the goods. In this case, I think it's good X. Okay, so this is a nice graphical derivation of how you get from an indifference curve utility maximization change and derive the domain curve. So if we start at point A, okay, so we've done this a few times. So we start with the budget line in the original difference curve and the consumer maximization equilibrium right there at point A, where the original difference curve is tangent to the original budget line. Okay, and then you can look down the lower graph where this shows the original price of good X, PX0, and the quantity of good X at the original point, which is Q0. So these Q0s are the same, and this is the original price, PX0. So this PX0 and this PX0 are the same, and this X0 and this X0 are the same. We're just looking at two different XY axes. Okay, then let's just do our analysis on top when the price of good X goes down. Alright, so when the price of good X goes down, the budget line shifts out, the red line shifts out like we've been looking at, and the consumer gets to a higher indifference curve because the cheaper good X now makes the consumer able to afford more goods, both X and Y. Actually, in this case, it looks like In this case, it looks like this doesn't really matter, but it looks like there's substitutes because I think it looks like point A is about less of good y. So this is the case when x and y are substitutes and the price of x decreases. Okay, now down here, if you just plot the lower price and the higher consumption of x1 that the consumer consumed. All right, so we put this shows price and quantity, which is basically the demand curve. So x0 and px0, we put those here, and then the price went down to px1, and the consumer bought more x. So what we're saying is, which is pretty obvious, that when the price of x goes down, the consumer buys more of x. So that's a negative relationship between the price of good x and the demand for good x, which is exactly the law of demand. So we just plotted the original price and consumption of x, and here's the lower price and the higher consumption. So we showed here just a simple connection dots analysis that when the price of x went down, the consumer bought more of it. So that just shows a nice snapshot of the demand curve for good x. Alright, so this is just simply how we can draw a simple demand curve from the changes in the utility maximization analysis. Okay, so the last two slides, don't worry about for this class. So the calculus approach to individual behavior, we're not going to do that. We're not doing that. We're not doing that. And the substitution income effects, I would like you to know, it won't be required in the homework or the exam, but it's nice to know how to draw and understand the substitution income effects. So here's some cases, and again, if you watch that video on the document, if you have more questions on the different outcomes of the substitution income effect, then you can look at those too. All right, so this is the chapter 4 document, the Word document. So we're done with the PowerPoint for chapter 4 for now. All right, so right now I'm just looking at this under chapter 4 on Blackboard, the chapter 4 Word document. All right, and these are just the ones we're going to look at are just the modified questions from the conceptual and computational questions at the end of chapter 4. All right, and there's those 3 optional videos again. The indifference curves and the substitution effect, income effect ones are pretty, I'd recommend watching those. And unless you're interested in the calculus, you can probably skip that third video. All right, let's look at some quick examples for some of the stuff we just did. All right, so a consumer has $400 to spend on goods X and Y, and the market prices of these two goods are the price of X is 10, and the price of Y is 40. All right, so part A is what is the market rate of substitution between goods X and Y? Okay, so this is pretty simple, but it's important to understand the concept is that we know from a lecture in the chapter that the slope of the budget line is the market rate of substitution, which is always negative px over py. Okay, if we plug in our prices to that definition, then negative price of X is 10 divided by the price of Y is 40. So our market rate of substitution is negative 1/4, and that won't change unless the prices change. So the rate of substitution is basically 1 to 4 because good Y is 4 times the price of good X. And so initially the market rate of substitution is negative 1/4. All right, let's suppose income increases by 400. And the question is, how does the $400 increase in income alter or affect the rate of substitution between good X and good Y? Okay, so we know from looking at the examples in the chapter that if just M income increases, if it goes up or down, that just shifts the budget line out by the same slope or ratio, right? So if income increases, the budget line shifts out by the same distance, or not the same distance, by with the same PX over PY rate of trade-off. So the 400, if only income goes up and the prices don't change, then nothing happens to the market rate of substitution because the prices didn't change. And so it's kind of a trick question because the $400 increase in income doesn't alter the market rate of substitution between X and Y. What would happen is the budget line would shift to the right, and the individual would consume more of X and more of Y, but they would keep consuming at that rate of trade-off at the basically 1 to 4 ratio, or if you went the other way, 4 to 1. Okay, so income changes don't affect the market rate of substitution, only price changes. All right, so let's look at number 2. So here's a little graph. So you can see we're in equilibrium at point A in the accompanying figure. Okay, and then it tells us the price of good X is $5. Okay, and so question A is, what is the price of good Y? So can we figure out the price of good Y from this graph and the price of good X? We really can, because if you look at, it gives us the two intercepts. The intercept here is 20, and the intercept here is 20. So that has to mean that the rate of trade-off is 1 to 1, because you're buying, you could basically exhaust your income by the same amount of both. So if you bought use all your income on Y, you could buy 10, or if you use all your income on X, you can buy 20. You could buy at maximum 20 of both. So that means the prices have to be the same. And if that's the case, we know the price of good X. We know the price of good X is $5, and if the prices are the same, then the price of good Y also has to be $5. So here's our general equation. PXX plus PYY equals M. Okay, and we know from the graphical analysis that the intercepts are M divided by PY and M divided by PX. Okay, and if both intercepts are 20, as you can see in the graph, then that has to mean that the prices are the same. And we already know one of the prices, so that means PX equals 5, PY equals PX, so they both got to equal 5. Okay, part B is what is the consumer's income. So we can figure this out based on the budget line relationship and the prices. Okay? So we know that the price of good Y and the price of good X are both 5, and we know that the intercepts are 20. So that means that if the intercepts are M over PY and N over PX, and both those intercepts are 20, as you can see by the graph, and we can figure out the income exactly from that. Okay, so if M over Py is 20, okay, right there, and the price of good Y is 5, and M divided by 5 has to be 20, which means that income M is 100. You can just confirm with the price of good X. So if M over Px is 20, and the price of good X is 5, then M divided by 5 equals 20, and again, we know for sure that the price, that our income is 100, and so basically if the consumer bought, if the price is $5, the consumer is going to buy, can afford an equal amount of both. So looking at that equation, 5 times X plus 5 times Y equals 100. So the consumer can buy equal amounts of both because the prices are the same. Alright, then at point A, how many units of good X does the consumer purchase? Alright, so we're given the point there at the original consumer equilibrium, point A, and it shows you right here that the consumer buys 10 units of good Y. Alright, so see that there. So we have the prices, we have income, and now we know how much Y the consumer produces. So if we know that, we can figure out X. So that's the only thing left in our equation. So we know Px, we know Py, we know Y, we know M. Let's just figure out X. And so at that point, how many units of X does the consumer purchase? So here's the general budget line equation. Let's plug in the things we know. We know the price of good X is 5. We know the price of good Y is 5. We know from the graph the consumer is buying 10 Ys. And our income is 100. So 5X plus 50 equals 100. And therefore 5X equals 50. And therefore X equals 10. 50 divided by 5. So the consumer is buying 10 of both. So it looks like they're buying a little more X, but that's only because the intercepts are distorted kind of. So this scale goes from 0 to 45, and this scale goes from 0 to 20. But at this point, this is 10 and this is 10, and which exhausts all the consumer's income. All right, then part D, let's suppose the budget line changes so that the consumer achieves a new equilibrium at point B. All right, what changes in the economic environment led to this new equilibrium? And also, is the consumer better off or worse off as a result of the price change? So let's look at what happened. And so we went from A to B, right? So if the budget line shifted like it did, right? So you can see that the intercept for Y on the Y-axis went up, which means the price of good Y had to go down. Right? So if the price of good Y goes down, this happens, and so nothing happens to the intercept for X. So it must mean that the price of good Y went down, and that's what that kink in the budget line shows. And so the first part is the price of good Y decrease. All right, and you know that the consumer is better off because he or she got to a higher indifference curve, and you should also know that given what we know, it's got to be the good X and good Y are substitutes. So look at the graph and confirm that you understand this. Okay, the new equilibrium, the budget line part shift to the new budget line was the result of the price of X going down, right? So that's why we got a higher intercept on the product Y-axis. Now look at point B. When the consumer went from A to B, they bought more Y but less X. So that's got to mean that they're substitutes, because the cheaper alternative, the substitute, was consumed more, and the consumer bought less of the more expensive substitute. So just by looking at the graph, you should be able to determine if X and Y are substitutes or complements. Okay, yeah, did you see that? Okay, so number 3, an example is, a consumer must divide 250 between the consumption of product X and Y. The relevant market prices are PX equals $5 and the price of Y equals 10. So A is just write the equation for the consumer's budget line. So this is pretty easy, but just so you know what the terms represent. So the general equation is PXX plus PYY equals M. And let's just plug in the prices and the income. So that means that 5X plus 10Y equals 250. Okay, suppose the price of good X increases to 10. Okay, write the equation for the consumer's budget line now. And how does this alter the market rate of substitution between goods X and Y? Okay, so the new budget line, plug in the new price, the PX, the price of X is now 10. So the new budget line is now 10 plus 10Y equals 250. Okay, and the market rate of substitution before, negative PX over PY. So before, Y was priced at 10 and X was priced at 5. So the price of Y was double. So the original rate of substitution was negative 5 over 10 or negative 1/2, right? Because X was a little bit cheaper. And now, if you plug in the new price of PX, they're both 10. So negative PX over PY is now negative 10 over 10 because they're both 10, which is negative 1. So the price directly determines the trade-off rate for the slope of the budget line. So before, when the price was half, it was a 1 to 2 trade-off. And when the prices are the same, it's just 1 for 1 because the consumer can buy the same amount of both if the prices are the same. Okay, this is number 9 in the back of the textbook, the modified version. Okay, right there. Okay, consumer's budget line for two goods, X and Y is 2X plus 4Y equals 500. So that's the budget line. Does the budget line change, part A, if the prices of both goods double and the consumer's income also doubles? Okay, so you can just double the things like it said. So we start with 2X plus 4Y is 500, and we doubled all the prices and the income, we get 4X plus 8Y equals 1,000, right? And really that's equivalent to, if you just divide both sides by 2, it's the same thing we started with. So 2X plus 4Y equals 500, that's what we started with. And so what that tells you is that if your income doubles, but also inflation doubles, then you're no better off. So you're only as good, your income increase is only as good if the prices don't change, or the prices don't go up. So if everything doubles, including your income and the prices, then you're left with the same point you started with. Okay, so no, the budget line remains the same if PX, PY, M all double. Alright, so given the budget line, can you determine the prices of the two goods and the consumer's income? And so we can, because we know how to do this, so we're just given the equation, but we know that that first term is PX, which is $2. The term 4Y, the price is in front of Y is PY, that's $4. And the last term is equal to the income, which is 500. Okay, so pretty simple examples, but it helps you understand kind of the terms and what's going on with the difference curve analysis. Alright, so any questions on any of that? Alright, so let's look at the homework assignment for chapter 4. Alright, so we're going to go through this right now because we still have a lot of time and we don't have a whole lot more to do besides chapter 4 today. Okay, so let me just go through this and I can show you, I can clarify it. I'm not going to do the whole example, but I'll show you how to do it. Okay, so you just have one question for chapter 4, and this is due next Friday. But remember, you still have that elasticity homework to do with all the data analysis for the elasticity regression. Alright, this is your homework question for chapter 4. Let's suppose you won $15 on a lotto ticket at the local 7-Eleven and decided to spend all of the winnings on candy bars and bags of peanuts. The price of candy bars is 75 cents, and the price of peanuts is $1.50. Okay, so part A is to construct a table showing the alternative combinations of the two products that are available. Alright, and so you can do this, some of this in Excel, or just in a Word document, or just on a piece of paper, whatever is preferable to your liking. But I'll show you what I did in Excel in case you want to do it like this. Okay, so I think think I'm sharing, right? Can you guys see the Excel file? Okay, great. All right, so the part one is asking you, again, you can do this, you can do it in Excel or Word or just write it, you can handwrite it if you want. But what this is showing you is there's the whole numbers, so you can consume the different combinations of both goods. And so your income is 15, right? You won the $15 at the lotto ticket. And you have to, every point on the budget line exhausts your income. You're going to consume some combination of peanuts and candy bars to consume all your income. Okay, and so we know that the price of candy bars is 75 cents and the price of peanuts is $1.50. Okay, so just put all the different combinations, like your equation would be 0.75 times px plus 1.50 py, 0.75x plus 1.5y equals income, equals 15. Okay, so you start with the same general equation where px plus pyy equals m, and the price of x is 75, so it's 0.75 times x plus 1.5 times y, and your income is 15. Okay, and so I just wrote a simple formula that shows basically that budget line and all the different combinations you can buy of peanuts good Y and candy good X. Alright, so 20 times, if you buy all candy, then 20 times 0.75 is 15. Or you could buy 18 items of candy and one bag of peanuts, and that's 0.75 times 18 plus 1.5 times 1, and that equals 15. So this just shows you all the combinations that consume different amounts of both the goods that get you to 15. So any of these combinations are on your budget line. Alright, so 20 and 0, 18 and 1, and all these different combinations all the way down to no candy. And if you spend all your money on peanuts, you can buy 10. Alright, so basically the trade-off is every time you buy 2 candy bars, you have to give up 1 bag of peanuts and vice versa. Okay, so that's the table is just this part here. Okay, and then part B is plot the data in your table as a budget line and a graph. And so again, you can do this in Excel, or you can do it in Word, or you can do it, just draw it on a piece of paper if you have a ruler, whatever. Okay, so your graph's going to be a straight line showing basically the budget line between candy and peanuts. So all those points are plotted, and if you buy all peanuts, you can buy 10. If you buy all candy, you can buy 20, and the budget line represents all those combinations of X and Y that exhaust your budget of 15. Okay, so what's the slope of the budget line? And that's what you can, I guess it depends on which way you're looking at it from, but since we usually look at it in terms of the y-axis. Okay, so basically like rise over run is your slope. Okay, and so every time every time this goes up by 1, then this goes up by 2. So it's basically 1 over 2. Right? The rate of trade-off of the slope is plus 1. So each time you get to a point, like this, up 1 over 2 gives you the same point of the line. So the slope, or I guess you could just use the rate of trade-off of the budget line is negative px over py. So that's just negative 0.75 over 1.50, which is negative 1 half. And so the slope of the budget line is negative px over py. And in our case, just plug in the prices, and that comes out to negative 1 half. Okay, what is the opportunity cost of one more candy bar and of one more bag of peanuts? Okay, and so this is moving from point to point on the linear budget line. And so what this says is for one good, if you buy more peanuts, you buy more candy, what do you give up for peanuts? And for the other one, if you buy more peanuts, what do you give up for candy? Alright, so if you look at the graph or the table, whatever, every time you buy 2 candy bars, you give up 1 bag of peanuts. So it's a 2-to-1 trade-off. And so therefore the opportunity cost of 1 candy bar is giving up half a bag of peanuts. If you look at in terms of peanuts, every time you buy 1 bag of peanuts, you give up 2 candy bars. And so the opportunity cost of 1 candy bar is half a bag of peanuts you give up, and the opportunity cost of 1 bag of peanuts is giving up 2 candy bars. All right, and then do these opportunity costs rise, fall, or remain constant as each additional unit of the product is purchased? And so the opportunity cost is the slope of the price ratio, and that's constant for the budget line unless one of the prices changes, which they haven't. And so the rate of trade-off, the opportunity cost is constant because the slope of the curve is the same. Okay, so that curve, which represents the slope of negative 1 half, always represents the same opportunity cost. So anytime you want to buy 1 more candy bar, you give up half a bag of peanuts. And anytime you want to buy 1 bag of peanuts, you give up 2 candy bars. So that's the same if you go from any point to a different point. Alright, so if you go from here to here, right, you gain 2 candy bars, but you gave up 1 bag of peanuts. And that's the same rate no matter what if you go this way. If you go this way, you gain a bag of peanuts, but you gave up 2 candy bars. So this rate of trade-off is always the same. You can move from point to point at that same ratio, unless the budget line changes. Okay, and then part C is this. Now, let's suppose you won $30 on your ticket, not 15. So what that means is your income increased by $15. So you're going to shift the budget line out. So you can show the $30 budget line in your diagram. And why would this budget line be preferable to the old one? That's pretty obvious because you can consume more of both goods. So for part C, you can just draw if you're doing it on a piece of paper, you can show the shift, like the shift out of the budget line with the same slope. So nothing's happened to the price ratio. The prices are always, PX is 75 cents and PY is $1.50. But your diagram shifted out. Okay, and if you want, you can make a new table showing how the consumer can exhaust the $30 now, because they have more, essentially their income doubled. So these are all the combinations of candy bars and peanuts that can potentially be consumed to exhaust the $30. Okay, and the new budget line just shifts out, so you can see the intercepts are the same, but the slope is still negative 1.5. Alright, so this intercept went from 10 to 20, and this intercept went from 20 to 40. Okay, so both the intercepts doubled because their income doubled, but the rate of trade-off is still always going to be negative 1/2 unless one of the prices change. Okay, so that one, not too bad, but it's kind of got a lot going on to understand the budget line and how it shifts and the rate of trade-off. And any questions on that homework assignment? Okay, so how do we know who's better off or worse off for consumers? Oh, so that's just because if they have more income, they can get to a higher level of utility. So they're 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 better off because their increase in income allows them to achieve a higher level of utility and to consume both or more of both goods. Okay, so this budget line would be preferable to the old one because the individual can consume twice as many candy bars, twice as many bags of peanuts at the same prices, so they can get to a higher utility indifference curve with the increase in income. They can consume double the amount. Okay, so that homework for chapter 4 shouldn't take you too long, but that's due by next Friday. And you put that into the discussion forum for chapter 4. And then that, whenever you finish this, you still got some time on the ELS 50 homework. I think those 4 questions. That's due there whenever you get that done. Alright, so just, we've already done homework chapters 1 through 2 and homework chapter 3. Homework chapter 4 is due next Friday, April 17th. And I think you still got about 3 weeks to do the ELS 50 homework, which is due Friday, May 1st. Okay, so any questions or anything you need assistance on for the Excel work for elasticity analysis for that homework assignment that we started last week? Okay, well, so next week we're going to do chapter 5 in your textbook, and then the chapter 4 homework is due. So you can look at the chapter 5 chapter in the PDF textbook if you want to look at that. That's what we'll do next week. So chapter 5 next week, and the chapter 4 homework is due. And let me know if you have any questions on your ELR 50 homework, anything you're doing in Excel, or the regression or data analysis, or interpreting the coefficients for the ELR 50. So yeah, that's really that's all I have planned for today. Looks like we'll end a little bit early, if that's okay with you guys. And yeah, so I'll stay on for a minute in case you have a question. And everyone's here. There's 31 participants, so including myself. That's 100% attendance. So you guys are good for attendance-wise. Everybody came today, so thank you for your perfect attendance today. All right, so yeah, you can go ahead and log off if you don't have any questions. If you do, let me know. But if not, I will see you next week at the same time. And have a good weekend, and please stay safe.